Now in the next part, we will learn how to read and write from a file. So in the MATLAB loopback that we have already executed, now we will write this vector onto a file and then once again read a vector from that file and use that vector inside this for loop for plotting purposes. So the first thing is to write this vector onto a file. Writing onto a file. Firstly, I will define the file directory, which I can copy from here. After this, I need to give a file name where the data will be written. Now for writing the data onto the file, if I check this tx hardware variable, we'll see that this tx hardware variable is a complex variable. So what I will try is, I will try to write this data in interleave format. For example, the real part of the first data will be followed by the imaginary part of the first data. Similarly, the real part of the second data will be followed by the imaginary part of the second data. Now to accomplish this, firstly, I'll open the file in write mode. Now once I've opened the file in the write mode, I'll need to define a variable where I will store the interleaved data. So for the dimensions of this, since my interleaved data will contain twice the number of samples as the tx hardware vector, so its length I will define as length of this tx hardware multiplied by 2. Now, I will take out all the real part of the tx hardware vector. Then I'll take out the imaginary part of all the imaginary part of the tx hardware vector. And then in the interleaved data, I will put these in interleaved format. So for that, in interleaved data, at every alternate positions, I will put the real part, and at alternate positions, I will put the imaginary part. So now we are done with writing the interleaved data. The next part that we must focus on is the data in TX hardware is very small. It is much smaller than 0. So in that case, we'll need to amplify the data. To amplify the data, I'm defining some amplitude in dB, and I'm defining some amplification factor. I'll keep it as 2 raised to power 15, which is around 32K. And I will define a vector whose size is same as the interleaved data. Now, to amplify it, I will be amplifying it this way. Firstly, the interleaved data will be divided by its absolute value, and then I will multiply it with its amplification factor and then the magnitude. Now I will be writing this amplified data onto the file. I will be using the fwrite function. I will open the file. I will write the data by. I will use the int16 format to write, and the machine format is IEEE little endian. And then I will close the file. So here, the writing part onto the file is done. The next part is reading from the file. To read from the file, I'll again need to open the file. So for that, I'll give the file directory, which is the same as before, and I'll give the file name. I want to read from the same file, so I'll give the same file name. And then I will open the file to read. I'll open the file to read. After that, I will receive the data from the file. Uh, the file from which I have to read. Then I'll give how much data I want to read. After that, I want to give the format in which I want to read. I don't want to skip any byte. That is the precision. I don't want to skip. And the machine format is IEEE little endian. So this is how now I've read the data from the file. Now I will close the file. Once the file is closed, now I know since I wrote the data in interleaved format, the data that I have received is also in interleaved format. So the next part is to regather the data in the original complex format that it was before. So for that, I will give the name data to be processed. That will be complex of data received. Uh, that will be complex of data received, and every alternate positions I will convert to complex. So with this, I can see and compare we will check with Y and we will check with data to be processed. If I see data to be processed and if I see Y, the data to be processed should be 12 plus 12 iota, and I'm getting 12 plus 12 iota. It should be minus 61 iota, and I'm getting minus 61 iota. So the data has been written properly. Let us see if the MATLAB loopback works. As we can see, the MATLAB loopback, after writing the data onto a file and then reading from it, is working properly. We can increase the speed of packet detection. by using this factor in the for loop. What this factor essentially does is that the first set of samples that will be picked is from 1 to 3000. The next set of samples now will be picked from 100 to 3100. So the sample picking rate has been increased. Hence, the packet detection rate will also increase. This way, the speed of packet detection can be increased. Thank you. And in the next part of the video, we will learn how to accommodate the antenna part into this code. We will adjust the spectrum of the code according to the antenna. We will set the center frequency of the code, and then we'll see if MATLAB loopback can be accomplished.